Fine, guys, let's start. Fine. So in the last two sessions, we are discussing NumPy. Fine. So we have seen the basics and we have seen a lot of functions. Okay. So in this session, so we'll see a few more functions of NumPy and we'll try to conclude the NumPy module. Okay. Fine. So let's start. So in the last thing which we have discussed in the last session is np.ravel, right? So what does Ravel do, guys? So Ravel will just extract all the given elements into one single list. Okay, so list of lists will be extracted into one single list. So that's the np.ravel function which will do. Okay, fine. So coming to next function, so np dot, fine. So I hope you remember what is np. Np is just the alias of numpy. Okay, so np dot diag flat. Okay, so what is this? Diagonal flat and 1 2 3 4. That means what you want in the diagonal position, you want these values 1 2 3 4. Okay, so that's why in the 1 2 3 4, which is diagonal, so it is having these values and remaining all will be zeros. Okay, so that is this function. So as I said, so all these are different functions, guys. So it's not that you are going to use each and every function which we are discussing over here. Most of these functions you might not use at all. Okay, but still we I'm discussing and we should discuss because you will get more familiar with this. Okay, so how to use the function. So the as such, this diagonal flat you might not use, but the way how you can use any function is more or less same. Okay, anything, whether it diagonal flat or try, or in other class we have studied arrange, line space, right? So how you can call the function, how you can pass the values, so that will remain the same. Okay, so that's why we are going through a lot of functions. Okay, so in the diagonal position you want 1 2 3 4. So in the 1 2 3 4 will be the diagonal position, remaining all will be zeros. Okay, so as we have seen in the previous class, you have something called as parameter as k. K is what is, so this the diagonal will be k equal to 0, and one step above this will be k equal to 1 2 3, and below will be -1 -2 -3. Agree? So over here if you specify -1, so this 1 and 2 will be presented in the -1 position. That means what, the actual diagonal will be 0. This will be k equal to 0. One step below will be k equal to -1. Okay, so in this position I want 1 and 2, so it will put 1 and 2 over here, and remaining all will be zeros. Okay, is this clear? Diag flat. Guys, okay, fine. So after that we have something called as try. Okay, so now what is try? Try is something similar to a triangle. So over here, what do we want? So we want 3 comma 3 comma 1. So that means, so this will be k equal to 0, fine, and this will be 1. Okay, so starting from that 1 position, so you will have all the values below that. Okay, above that will be 0. Okay, above that will be 0. Fine. So because this is k equal to 1, agree? This is k equal to -1. The actual diagonal will be 0. Okay, so we are specifying 1. So from 1 till all the below, it will have some values, and above that will be equal to 0. Okay, and k equal to 3 by 3, k equal to -1. So now over here, if you see k equal to -1, so that means what? This is -1. So the actual diagonal is 0, and this is -1. So everything below that will have 1 values, and remaining all will be 0 values. Okay, fine. And coming to np dot triangle lower, this is just try. Okay, this is TRIL lower, and you have TRIU upper. Okay, so that means what? So the lower triangle will over here you will consider the lower triangle, and over here you will consider the upper triangle. Okay, so that means what? So you are having 1 2 3 4 5 6 7 8 9. Okay, but lower means what? So you're saying 0. That means you want only, okay, this is what? This is k equal to 0. Okay, and just below this only you want the values. Okay, above that everything will be zeros. Okay, above that everything will be zeros. So here you are specifically specifying some values. If you don't specify any values, it will directly consider 1. Okay, and remaining will be 0 by default. But here you are specifying some values, so it will give those values. Okay, but actually if you don't give this, okay, so if you don't give this, what should be the value, guys? It will take all 1 2 3 4 5 6 7 8 9. Okay, just if you if it is not trial, okay, if it is not trial, so just np dot array Okay, input dot array is what? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, but when we are saying try lower, try L, okay, and we are saying 0, that means this is 0, right? So this is 0. So it will consider only the values from this and the below it. Okay, lower triangle. Okay, this is lower triangle. Remaining everything, the 2, 3, 6 are replaced by 0. This is zeros. Okay, but same thing if you do it for what do I say, upper triangle. Okay, the same thing if you do it for upper triangle, the upper part will be given some values and the lower part will all be zeros. Okay, so over here if you say triangle U, okay, so the upper part, the same thing. Over, see, this is actual triangle, actual array and when you say try L with 0 position, that means from 0 all the lower will be given values, remaining will be zeros. When you say upper, so from this diagonal position, all the this upper triangle will be given some values, remaining all will be zeros. Okay, and same thing over here. So and this position also you can change. Here it is 0, but if you want to give 1, so what is 1 over here, guys? So this diagonal is 0 and above this is 1. Okay, so only from here, from 2 to 6, 2, 3, 6 will be shown and remaining all will be zeros. Okay, so just here if I just say L, can you just guess what I will get? What I will get? Yes, can you answer? If I say triangle L and when I say 1 over here, so what will be the answer? Oh no, you not get this.
In place of zeros, we can get
What in place of zeros? What we can get?
1.
Where? Over here? No, tell me like 1, 2, 3, 4, 5, 6, 7, 8, 9. So what will be the first row values? See, I'll explain again. So when I'm saying, when I put it over here, U, so what is actual matrix? This is actual matrix. Okay. So and what is this? This is a K position. Okay. So when I'm giving K equal to 1, okay, what is K? The diagonal value K will be 0. Agree? And above that will be 1 and last one will be 2. Okay. And this will be -1 and this will be -2. Okay. The diagonals, are you getting when I say diagonal? So this part, this is 1, 2 and 6 will be -1, 3 is -2 and 4 and 8 will be -1, 7 is -2. So when I'm saying try U, that means take the upper triangle. Okay, from where the upper triangle, from one position. What is 1? 1 is over here. 2 and 6 is the upper position. I mean K value. So 2 and 6, from this 2 and 6 consider the upper triangle. So this triangle it will take 2, 3, 6 are considered. Okay, apart from that everything will be 0. Did you get this?
Yes, sir.
Then okay, if you now tell me, when I give L, what will be the answer? Meghana saying repeat again, sir. Okay, fine. See, Meghana. See, what I'm saying over here is, this diagonal is there, right? This diagonal is referred by K equal to 0. This diagonal is there, right? Upper, this diagonal, one step above, this is K equal to 1. this diagonal, only this value is k equal to 2. Now lower diagonal to the main diagonal. Main diagonal is this one, k equal to 0. This is k equal to -1. And this is k equal to -2. Is this clear, Meghna? Yes. Okay. Now what is happening over here is here we are. Okay, so when you did not understand that, so I think you did not understand this also. Where was that? Try. Okay, fine. See here, try u means what? Take the triangle, but u means upper triangle. Take upper triangle. If actually, what is this matrix? Forget about this try u or everything or this position. First of all, what is this matrix? This matrix is what I have just printed over here. This is a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. What I have just shown, this matrix is the actual matrix. From here, sorry, from here, what I need to take, I am taking triangle U, upper triangle. Okay, upper triangle from where? Okay, see, by default, if you take 0, that means from 0th position. What is this 0? This is k value, the one which I'm just showing, right? These values is this value. Okay, so consider k equal to 0. From that, take the upper triangle. That the meaning is this. That means what? So this is k equal to 0. Okay, that means this k equal to 0. From this, take u. What was there over here? U means upper. Okay, that means above. So from 0, take all this. 0, 1, 2, take all this. That means what? Take 1, 5, 9, 2, 6, 3. So this triangle will be considered. And remaining part will be zeros. Okay, remaining part will be 0. That's why you got 1, 2, 3, 5, 6, 9. Why? Because 1, 2, 3. Okay, so this one I should take, because from this is k equal to 0. From this upper triangle I should take. That means if I just show you this triangle I am taking. Okay, and remaining everything is 0. Is this clear? Okay, so now similarly, what is happening here? Exactly the same thing, but here what I'm considering, same upper triangle from which position? Not 0, 1, position 1. Okay, so position 1 means what? So this is 0. Okay, now this is 1. So from now I will consider from 1 and above. That means what? I'll consider from 1 and 2, only 1 and 2. Okay, only 1 and 2. Agree? That means what I will get now? I'll consider only this triangle. This triangle, what you're seeing, 2, 6, 3, only that triangle I will take. And remaining everything will be 0. Okay, that means what? See, only 2, 3, 6. Remaining everything is 0. Because I'm considering it from k equal to 1 and above. Why above? Because I have U, upper triangle. Is that clear? Now, when I say L, now tell me, when I give L, okay, and when I give 1, from this, can you tell me what will be the answer? And this is triangle, lower triangle. Okay, so what I'm considering here, triangle L, that means lower triangle from 1. Okay, or for simplicity, let's say -1. Okay, so lower triangle from -1. So what I'm saying here, I want triangle L from -1. What was the answer?
One, 2, 3 as 0, 5, 6, 9 as zeros, 4, 8, 7 will be the numbers.
You will get 1, 2, 3.
No, sir, it turn into a zeros if we
Okay,
give
so
an
okay. So,
-1.
you can just tell me what values. No, you just tell me what values we will get. It will consider. Remaining everything will be 0, but just tell me what values we can see.
487.
487. Okay. So that's 487. Perfect. So when I say 1 now,
Two, 6, 3.
you're saying 263 will be seen?
Yes. Okay, low. Okay, lower. Lower means
Yes.
except 3 we see also.
Correct. Okay. So when k equal to 1, simple, when k equal to 1, from here, it will start from here. Okay. Whether it's lower or upper, it is lower. So consider this triangle. Okay. It will get all values, but this will be replaced by 0. Okay. So that's what we got. Clear? Okay, perfect. So that's regarding the triangle diagonal fact. Next thing is random number generation. Okay, so this is simple. So we already know that we have a library called as random. I think we have discussed in the Python. Okay, so did we discuss this random library? I hope we discussed, but you guys confirm.
Yes. In Python, we discussed.
Okay, fine. So from how we can generate float values between any two given numbers or integer values, etc. Right? Okay. So now here we are saying simple np.random.rand means what? So generate a 2x3 matrix. Okay, generate a 2x3 matrix. Inside that, fill all the values with some random values. Okay, but it will range from 0 to 1. Why? Because rand will give the values between what? It will just give you values between 0 to 1. Okay. So import random and random.rand of rand int. Okay. In Python, we have let me Google Python random module 0 between 0 and 1. So what was the function? Random. Okay, let me see. Random of 3 takes no arguments. Okay, fine. So yeah, so random is creating some value between 0 and 3. Okay, so just to get confirmation for I in range of 10, so you can print. So that the same thing. So see, I also don't remember. I can understand, I can explain, but obviously all these functions I also don't remember, right? So it's completely fine. So in future also you can just Google it. Okay, so that will. So for range of 10, so I'm printing C. So random.random will generate a value between 0 to 1. Okay. So now similar function in Python is random.rand. Okay. So here, because we need to create arrays, okay, in NumPy, so you need to specify the shape. Okay, 2, 3. So it's saying create a array with 2 rows and 3 columns, but fill everything with some random values. Okay, see, every value is between 0 to 1. Okay, so that is regarding the random. Fine. And also if you see here, now you also have rand n. What is n? N is a normal distribution. Okay, so numbers from normal distribution is 0, mean, and standard deviation. That is standard normal. Okay, so these values are generated from a standard normal distribution with shape what? 4 rows and 3 columns. Okay, 4 rows, 3 columns. And over here, what are the values you are getting? So every value will be, see, it's a standard normal distribution. What is this? I think we have extensively discussed what standard normal distribution, where mean equal to 0 and standard deviation equal to 1. And when mean should be 0, obviously some value should be less than 0 and some value should be greater than 0. Okay, so then only the average value will be 0. So that's why you can see some values are negative and some values are positive. Okay, some will be very closer to 0. And if you do the mean of this, it will be 0. And the standard deviation will be equal to 1. Okay, so these values are created from that type of distribution. So if you want that, you can do it with random rand n. Okay, n. Fine. So after that, yeah, so you have np.random.rand integer. So if you want to just create one random vector from 1 to 10, okay, you can integer value you will get from this range 1 to 10 only you will get, okay, some value. So you can change this, so anything 10 to 50, so it will generate one particular value. Okay, so similarly, so 1 to 100, okay, so here you want to create the same thing, but here instead of one value I want to create a matrix, okay, an array. So I want to create a 4x4 matrix, okay, 4x4 matrix. Inside that, fill every value such that each and every value is coming from random integer between 1 to 100. That is the value of this. Okay, that is a value of this. So did you get that? So creating 4x4 matrix. Okay, first let me run this. Okay, so if you see, creating a 4x4 matrix, 4 rows, 4 columns, and fill every value inside this with some random integer that is from 1 to 100. Okay, so you can check every value should be greater than 1 and less than 100. Okay, that is how it is created. Okay, and if you just put this as 7, so I think you got something. Okay, 7 will not, yeah. So if you consider this, so you can take it as an example of a rolling of the dice. Okay, so when you roll a dice, what should be the value? Guys, maximum you will get minimum value 1, maximum 6. So it can be taken as that example. Okay, and similarly the other example, okay, 20 random samples when you are drawing. Okay, so this is just what earlier you are creating a matrix. Okay, 4x4 array. So here it is a single only one row, and you are generating 20 values. Okay, and each value will be between 1 to 7. Okay, 20 values are generated from 1 to 7. Okay, so you can give any shape and form. Fine. Now next thing is called as reshaping. Okay, and what is this reshaping? So you have np from numpy.random import rand int. Okay, so same rand int I am importing as array. Okay, this is aliasing. Okay, so from I need to use array. So what is this? So from 1 to 100 generate 30 values. Okay, so from 1 to 100 generate 30 values. Okay, see, observe this, guys. So when you are passing some value, okay, to the random integer, so always remember the 3 values. First is starting, ending, and count how many values you need to create. Okay, similarly here also 1 to 100. From 1 to 100 generate how many values? 30 values. So as you can see, 30 values are created. Okay, so for example, if I just show you, okay, see, these are 30 values. Okay, these are 30 values. Okay, these are still just an array. Okay, these are just an array. Okay, so what is this? 30 values are there. Okay, 30 values are there. Okay, so now if you want to just reshape this, because we are having 30, so obviously you can do it this way. So what I'm saying, see, so if you just reshaping it with B, see, what is this reshaping? I'm saying total 30 values I got, total 30. That 30 reshape in such a way in this 2, 3, 5. Now this 2, 3, 5 is what? It is a shape values. Okay, so you're having 3 values. These are shape values. Earlier, when you are passing to the random modules or functions, when you're passing 3 values, the value of 3 values is different. When you're passing to array, what are this? This is a starting value, this is an end value, this is a count, how many values you want to generate. That is done. But now when you're reshaping, you're again passing 3 values. Now what are these 3 values? These are the shape of this, how you want to convert these 30 numbers. Instead of in one single line, I want to reshape into a different form. That is what 2, 3, 5. And if you remember 2, 3, 5, in the last class, we have discussed very clearly that the last two will be rows and columns. Okay, these are rows and these are columns. And this will be one more dimension. Okay, so obviously how many rows will be there? 3 rows and 5 columns. Okay, like this, you are creating two sets. Okay, so if you see, in each set you are having 3 rows, 5 columns. Okay, this is one set, 3 rows, and 1, 2, 3, 4, 5 columns. Here also 3 rows and 5 columns. Done? We have done.
Yes.
And like this, with this row and column values, you are creating 2 sets. Okay, this is one set, this is 2 set. Okay, But important thing is the total number of values should always be 30, because that is the number of values you're creating. You cannot change this because 30 are the values. You can play anything, but the 30 should be matching. That's why if you multiply all this 2 into 3 into 5, it should become 30. Okay. So 2 3 6 6 5 30. Okay, total values will be 30. That 30 values you can juggle and shuffle and make any different shapes. Okay. For example, you can tell me some other numbers. Okay. For example, if I just change it into 6, so obviously what is the value? 6 is 18, 36. This will not work. Okay. See, it is saying, so it is saying total values of 30, but I cannot shape into 2, 3, 6. Why? Values are only 30, but if I want to reshape into 2, 3, 6, what should the count? 3 to 6, 6, 36, 36 value. From where I will get extra 6? I cannot do that. Okay. But if I create some other values, okay, 30. Okay. So you can just tell me 5. Okay. 6. For example, 5, 6, 30, and one more just dimension is 1. Okay. This will work because 6 is 30, 30 into 1 also 30. That means what? 30 values I'm creating with 5 rows, 6 columns. Okay. Last two will always be rows and columns. Okay. This is row and 6 is columns. Okay. So 5 rows and each in 6 columns. Like that, only how many sets? Only one set I'm creating. Okay, only one set. Clear?
Yes, sir.
Okay, and this you can just shuffle also. See, and instead of saying on 6, so I'll say 6, 5, 1. Okay, so this will create what? 5 each set, 5 rows and 1 column. See, 5 rows, but only single column. Like this, how many? 6 sets I want. Okay, you will have 6 sets. Okay, see, 1, 2, 3, 4, 5, and the last one is 6. Okay, so once you have these values which multiply to 30, you can do any different combinations. Okay, fine. And after that, we have something called as in the reshaping. You can also give negative value, but when you pass negative value, so it will just avoid that. Okay, just in case if you should not pass that, but even if you negative value, so it will just consider the appropriate value. Okay, so it will just take 6 is the number of rows you are saying, but remaining part it will obviously take as per such that it will match into 30. Okay, it will not consider this negative value. Okay, but we generally don't use this. I'm just showing, but mostly we can do this perfect reshaping into any shape and form. Okay, so better let me put it as 1 into 5 into 6. Okay, fine. And shape of this we have already seen. Okay, and after that yeah, so it is just showing the values. Okay, the A is looking like this and B is looking like this and C is looking like that. Okay, fine. And after that, yeah, so there is something called a sort. Okay, so if A is this, what is this A? So what, from 1 to 100, print 10 values. Okay, so these are the 10 values. And if you just want to sort, very simple, np dot sort of A. What is A? A is our this value. Okay, so these are the values and just sort it. I'm just sorting it into ascending order. Okay, clear. And also what do we have here? Same thing. So over here, you are creating from 1 to 100, take 25 values. Okay, from 1 to 100, take 25 values, and that 25 values I want to reshape it into 5 into 5. Can I do that? First, you need to check this. Yes, this is possible, because why? 5 into 5 is 25, and 25 values I'm creating. That's fine. So, but if I do this, is this possible, guys?
No, sir.
Okay. Now?
Yes, sir.
Okay, fine. Okay, so that is possible. So you just need to check. So this last one is how many values you are taking, and this is a starting range and ending range, and this is whether how much water reshape you are finding. Okay, when multiplying this, it should tally with the number of values. Okay, fine, because you cannot create and delete any values. And over here, it is also sort. Okay, merge sort we are saying. So what is this merge sort? So over these are the values, right? So for example, let me print M. Okay, so I'm printing M. Okay, so once you print M, this is the actual M. Okay, now when we are sorting, so np dot sort, instead of this is not a single array, this is a matrix sort of thing, right? So this is a single, you can just use np dot sort. Okay, but when you're having a matrix sort of thing, so there might be different ways of sorting. Okay, over here when you're saying access equal to 0 and kind equal to merge sort, so can you observe what happened over here? So it has sorted all the columns. Okay, can you observe? So every column is sorted from ascending to ascending order. Yeah, so it's starting from the lowest and it is increasing to the highest. Okay, you can observe every column. Okay, but the rows are different. Okay, rows it is mixed up till still. Okay, so 85, 46 it's mixed up, but if you can check that every column is sorted. Do you agree?
Yes, sir.
Okay.
So
If-
what is the axis is equal to?
yeah, that is what I'm saying. So axis equal to 0 means it's for the column. So but if you say axis equal to 1, so now the rows will be sorted. Okay, earlier the columns are sorted, but now the rows are sorted. So if you see the row 8, 18, 39, it is sorted. Only the rows, just observe the rows. Okay, every row is sorted, but the columns, they're mixed up. See, 70, 96, 82, 86, 84, this is mixed up. Okay, but the rows are sorted. Every row is starting from the lowest value and going to the maximum, starting with lowest, going to the maximum, starting lowest, going to the maximum. Okay, axis. Okay, axis 1 is for, so just let me if I put it here, axis 1 for row, 0 for column. Okay, so if I just show you for 0 again, so if you see here, all the columns are sorted now. Okay, but the rows are again mixed up, but every column is sorted. Okay, is it clear?
Yes, sir.
Cool. And after that, you just have, you can take the minimum and maximum values. Okay, m dot maximum. Okay, m dot minimum values. Okay, m dot maximum and b dot maximum. Okay, so the just maximum values from this. Okay, and what's more? Okay, and the other thing is what is the location of the maximum value. Okay, for example, where is the m? Yeah, so if I just create the m, so I'll just show you a practical example. So this is my m. Yeah, so over here, if you see, this is my m, fine. And what is the maximum value over here? 92. Okay, and what is the minimum minimum value of m? Let me take m dot minimum. Okay, so m dot, fine. So the maximum value is 99, 98. Okay, these are random values getting generated. Okay, every time I run, you will get a different value. Okay, because array is a random model. Okay, so every time I run, it will get a different value, but it will just take the maximum value from the complete matrix and the minimum value from the complete matrix. Okay, max and min, simple. And after that, this is my m. Okay, and over here, if you just see, what is this m dot argmax of argmax of axis equal to 1. Okay, now what is axis equal to 1? Axis equal to 1 is it is for the rows. Okay, and yeah, for the rows, in the rows, what is the maximum positions? Okay, so for example, if I see, let me just check. So axis equal to 1, over here it is, this is the value, and in this, this 1 is the value, 0, 1, 2, 3, 4. No, oh sorry, this is the rows, right? So in the first row, what is the value? Yeah, so axis equal to 1 is for what, guys? Rows or column? Axis equal to 1 is for row. Okay, and for every row, let me take the maximum value. Okay, so in this row, what is the position of the maximum value? This is 0, this is 1, this is 2, this is 3, this is 4. Okay, so in this row, what is the maximum value position? 1. Agree? In this row, what is the maximum value position? 4. Agree? In this row, what is the maximum position? 1. Agree? In this row, it is 3. Okay, and in this row, it is 2. Did you get this?
Yes, sir.
Okay, so what is this matrix? It's 1, 4, 1, 3, 2. Simple. Okay, so it is 1, 4, 1, 3, 2 is that. Okay, fine. And you can just change this to 0 also. Okay, so in 0, what is the value? So over here it is 1, over here it is 0, 1, 2. Okay, this is 1, 2, or it is 0, 1, 2, 3, 4. Yeah, it is 4. Over it is 0, 1, 2, 3. It is 3, or it is 0, 1. Okay, 1. Okay, fine. Same thing you can go for the other values also. So b dot argmax. Okay, so it will give you that value. There is one difference you should notice here. One is getting the maximum value is 1. What is the maximum value is 1. Second thing is the argmax is what is the position of that value. Okay, position of that value which is having the maximum value, that is argmax. Both are important. Okay, sometimes you need this, sometimes you need this, sometimes you need the actual value. See here, when I'm saying m dot max, it is giving the maximum value, I don't know where this 98 is. 98 is wherever it could be. It could be present anywhere, but it is giving the 98. That is the maximum value. That is just max. But if you want to know what is the position of this 98, then you need to go for the argmax. Okay. Then you need to go for the argmax. Getting?
Yes, sir.
Fine. So remember, don't get confused. Argmax is argument. Okay. That argument position you will get wherever you are having max, and similarly you will also have argmin, but maximum and minimum value the actual values. Argmax is the position of the values. Okay, fine. So after that we have something called as indexing and slicing. Okay, and this is this I think we have already discussed in previous class, but I'll just give you overview. Okay, input dot arrange. Okay, what it will do, it is similar to the range function in Python. It will just create. Okay, and this position array of 7 is what 7th position it will take, and 3 comma 6 comma 2 is what 3. It will start with 3. Go till 6 minus 1 5, and at a step of 2. Okay, that means what? So this is start from 3 and go till 6 minus 1 5. That means from 3 to 5, and at a step of 2 means start from 3 and 5. Only 3 and 5 you are going to get. Okay, that's fine. And what is this? Start from first position and go till 4 minus 1 3. Okay, so from 0 1 2 3, that is this. Okay, and what do we have? And it is also same thing, -1 7 -1. Okay, start from -1, go till 7 plus 1. Why? The index is negative. Okay, so you will start from -1. Okay, go till 7 minus 7 plus 1 8, but in the negative direction. Okay, so that will be the value for this. Fine. And I think we have already discussed this in the Python. So if you're having any doubts over here, you can just let me know, or else I'm just giving the overflow. Okay, start from -1, go to -6 plus 1, and in the positive direction. Okay, so these are the values, just whatever you are seeing over here. Okay, clear?
Yes, sir.
Fine. And over here you are starting from the -1, going in the positive direction, but you need to reach the -6. Okay, so that will not be possible. Okay, and this is simple, start from 0 to 21 at a step of 2. Okay, fine. And these are start 2 4 9. Okay, array of elements are 2 4 9. Okay, yeah. So this you're taking multiple values. Okay, you're passing multiple see, this is array. Okay, and from this array, if you just pass 2, you will get one value, but you can also pass multiple indexes. Okay, so the index you are passing as a list. Fine. So 2 4 9, what are the values of 2 4 9? Okay, 4 8 and 18. Okay, so you can also take these values. Okay, this is passing the indexes of the list. These are not the values. Values are already created from this array. You are taking the values. Okay, that is how you can pass. Okay, clear, guys? Any doubts? Are you guys following?
Yes, sir. Following.
Okay, cool. And after that, we have what? You have reshape. Okay, just reshaping this. But here, yeah. So this one you need to understand. So here, first let me type this. Okay, and also I'll show you. Over here, yeah. Which one should I show? Yeah. Yeah. So this is a matrix which I have created. What does this do? We have seen from 10 to 100, take 15 values and reshape it into 3 comma 5. 3 5 is 15, 15 possible. Done. So this is a matrix created. Okay. So first let's try to print the matrix. Okay, this is a matrix. From here, what we are taking, see, one mat of 1:4 comma 3:5. Okay, so observe this 1:4 and 3:5. Wherever you're having comma, right? So this will be rows and this will be columns. Okay, so this is, you're slicing the matrix. Okay, so rows and columns. This rows he's saying 1:4, and this columns is saying 3:5. Okay, and what are the rows? Rows are from 1 to 4, right? 1 to 4 means what? take only from 1 to 3. Okay, take from 1, 4 minus 1, 3. So from 1 to 3. So this will be the 0 row, this will be the 1 row, this will be 2 row. Okay, so when you're saying 1 to 3, I have only till 2, so I will consider these two. What I will consider? This one and this one. So you remember, slicing will never give any error. One single value, if you're trying to access, if it is not present, you will get error. But in slicing, either in Python or NumPy, even though that row is not present, you will not get an error. Wherever it is present, you will consider till that point. Okay, so from, see, you might thinking this is having only 3 rows. Why I'm getting 4? Sorry, it is having 3 rows. The index is only 0, 1, 2, but I'm saying 1 to 4. 1 to 4 means what? From 1 go till 4 minus 1, 3. Where is the index 3 row? It is not present, but that's still fine. Whatever it's present, it will take till that point. Okay, from 0, 1, 2, it will consider from 1 to 2. That means I have considered these two. Okay, and now coming to column. Okay, this comma left side will be rows and right side will be the columns. Okay, columns, he's saying take 3 and 5. Okay, now over here it will be what? 0, 1, 2, 3, 4. Okay, so over here from 3 to 5 means what? 3 to 4. Okay, so that means what? This one and this one. Agree? So if I just draw, so this one is the rows I should consider, and this one is a columns I should consider. So where is the intersection happening, guys? This small matrix, whatever you are seeing over here, the last these 4 values, that is the intersection values which I will be getting. And what are those values? That is this matrix 56, 61, 17, 13. Okay, so if you're getting doubt, so I'm just erasing, you see these 4 values 56, 61, 17, 31. Is it clear, guys, how you can consider different rows and different columns combination? This is very important. If it is not clear, let me know. I'll repeat. Clear? Okay, great. Okay, fine. So similarly, you can also take it as this way. So from 0 to 3, I'm considering. So 0 to 3 means what? So this is 0, 1, 2. Okay, and from 1 to 3 columns. Okay, this is 0, 1, from 1 to 2. Okay, that means this and this. Okay, okay. Oh, sorry, my bad. Over here, it's a catch. Here he is not saying 3. Here earlier he was saying 3 is to 5. Okay, but here he's saying 1 comma 3, guys. Okay, so that's an interesting point. Earlier when he's saying 3 is to 5, that means from 3 take all the values till 5 minus 1, 4. For example, if you're saying 3 is to 10, that means starting from third index column, take all the columns till 10 minus 1, 9. That means what? 3, 4, 5, 6, 7, 8, 9. Okay, that is to. But if you want a specific columns, you can make it as a separate list and pass only those. You see 1 comma 3 he's saying. He's not saying 1 is to 3. 1 comma 3. That means what? Just 1 and 3 columns. Rows I want from 0 to 3. That means from 0 is to 3 means 3 minus 1, 2. That means 0, 1, 2 rows I want. That means what? This is 0, this is 1, this is 2. That means he's saying indirectly take all the rows consider. But in that all the rows, I don't want all the columns. I just want 1 comma 3. Just 1 row. That means index 1 column and index 3 column. This is 0 index, this is 1 index. Okay, I want this one, and this is 2. I don't want, this is 3. Okay, this one I want. So that means what? He's taking only this one and this one. Okay, why? What is the intersection? So if I draw like this and if I draw like this, so the intersection is happening at only these 6 places. Okay, so that's why I'm taking only this 60, 17, 98 and 13, 28, 32.
Yes, sir.
Clear?
Clear, sir.
Okay, so fine, guys. So what I will do here is, so let me see. So for example, I will just put this over here. Okay, so and also let me print this. Okay, so these are the values. Okay, so for example, let's take some square matrix. It will be better. Okay, so let me go for I want a 4 by 4 shape. Okay, so 4 by 4 will be obviously 16. Okay, so this is my matrix over here. So if I want to, if I just take one, okay, I'll take 0:3 and 1:3. Tell me guys, when this matrix, if I take 0:3 and 1:3, what is the values I'm going to get? Slicing matrix is very, very important actually. So you will find it in many places.
We have to consider rows 36, 92, and 90.
Wait, 36, 92, and 90. Okay.
Columns 79, 72, 14.
Okay.
Okay, 0, 1, 2. Okay, 2. So 0, 79, 72.
Okay. Okay. So that means what will be the values? It will be this column and this column. Agree? So where is the intersection we are having? So in these 3 rows, I'm taking these columns. Okay. So this part.
Sir.
That means this part.
Yes, sir.
Let's see. Fine. 79, 72, 56, 50, 77, 67, 52. Perfect. Okay. Now, if I change this to, for example, I'll just say 1:2 and just 0:2. Now,
$92.
only 92? Hmm?
92, 77. Ah,
Hmm.
no, sir.
Yeah, let me see. Meghna, what you're saying?
56.
Sorry, 92, 56. I didn't get you.
56.
Okay. Sirisha?
192, 0, 1, 2, 1, intersection 2, 56. 92, 56, sir.
Sure. Okay, perfect. Great. Now the other way around is you can specify specific columns. Okay. So over here, if I take the same example, so what will be the answer? 0 to 3 and 1,3. This one. Tell me guys.
79, 56, 67.
79, 56,
67.
67.
1, 2, 0, 1, 2. Okay. 72, 77, 52.
72, 77, 52. Agree, Meghna?
Yes, sir.
What happened?
It's considered third
This is index,
third
guys.
column.
This is not slicing. Here it will do here it will not do -1.
Okay, sir.
Okay. This is
Yeah, sir.
slicing. When you're that means range from 0 to 2, I'm saying, then it will consider end -1. That means from 0 to 1. Here what? I'm specifying specific columns. I'm take first index column, take third index column. That's it. It will not do -1. These are all individual values. Here it is like a range from 0 to 2. There it will do -1. So here it will take first index column. So that means what? This. And third index column. That means this. Is it clear?
Yes, sir.
Pakka.
Yes, sir.
Now? Hmm?
36,
36, 9.
72.
Wait. That is 672. Huh? 92?
90.
90, sir.
90?
52.
52. What happened? In the 0, 2, that means what? Which column? 0th row and second row. Okay, this row. And in that 0th column and second column. Okay. So over here, what it should give actually? This 36, 72, 90, 52. It should give 36, 50, 90, 122. Strange. Why did it give this? Why did it give this 0, 2? That's strange. Just a second.
I may think it's considered
0 and second row and 0 and second row. 25, 91, 75, 75. That should be the case actually. Let's see. Oh, sorry. If I just remove this 25, 91, 40, 48, 96, that's perfect. And if I just 0, 2, 0, 2, column 0. Okay, let me try 1, 2, and 1, 2. Okay, 1, 2, 1, 2. 13, 45. It should be 1 and 2, 0, 1 and 2, and 1 and 2. All right, so it should be 13, 96, 81, 45. That should be the case, ideally. But fine, guys, let me check this and I'll let you know. So ideally, that should be the case. Okay, so I will check, because obviously when you are doing, so when you are doing this way, right? So when you're doing this way, 1:2 is considering from what, row 0 and row 0 to 2 minus 1, only one, this, okay, this row, and inside that 0th column and second column, okay, 0th column and second column, 48, 96, okay, this is understandable. But in the same sense, okay, the same sense, when I go it for 0 comma 2, okay, and when I do this, ideally what it should print, guys, 0th row and second row and 0th column, column 0 and second column, okay. So inside this, what are the values are matching? So it should be 25. 91 is also matching, right? Because I'm considering 0th row. Inside that second column also it's matching, and it is 75 and 45. It should be the case. But fine, guys, let me note this down and I will let you know. Okay. Thanks. I also came across a new thing. Okay, fine. Sure. Now, apart from that, is this clear, guys? The slicing and taking the specific columns and rows. Okay. Sorry, guys, just give me a second. Yeah, guys, sorry, small work. Okay, so fine. So after that, so here when you are taking one particular row, single row and single column, it will just take the that single element. Okay, 0th row and 0th column. So 13 will be the 0th row and the 0th column. Okay, fine. And taking 1 and 2 first row, I mean first index row and second index column. Okay, so first index row and second index column will be the 75. Okay, so similarly this is only, it will take only the one value. Okay, and what it is saying, entire row at the second index. Okay, so when you don't specify any see here, am I audible?
Yes, sir.
So here you are specifying only what? Or here you're taking only one value. That means it will be considered as a row. That means it will take all the columns in that row. And which column I am specifying? It is, I am specifying the second column. Okay, so second index column. Okay, it will take the second index column, and this is what it is just taking. When you don't give any values, that means take all the rows. Okay, but only third index column. Okay, so I would advise you to experiment. Take a matrix, experiment all these different combinations. When you give only this one value, that means it is just that particular row. This is slicing, this is taking a specific values. Okay, so experiment with different matrices, guys. Okay, so please do, and you can also let me know if you're having any issues. Okay, but that thing which I've just checked, I will let you know. Okay, but make sure you're comfortable with slicing, indexing, and only one single index. Okay, and over here matrix of 1 3 3 5, same thing, same story. Okay, fine, guys. So yeah, so over here now, second thing is, see, this is also one more function. Okay, so here what we're saying, np dot array r8. Okay, same thing, creating a matrix, but here what I'm saying, matrix greater than 50. That means from the values wherever you are generating. Okay, so wherever you're having greater than 50, I'm just asking. Okay, so it will check each and every, wherever it is greater than 50, it will just consider it as true. Okay, wherever it's false, it is giving all false. Okay, so it is just giving the Boolean value. Fine. But before that, are you comfortable, guys? Did you follow that the slicing part and specific index part and single value part? Anything difficult over there? Sorry, Meghana. I think you might be having some network issue today, but that's fine. What did you say? Clear, sir. Okay, great. So in subsetting is this clear? Just, yeah, we're just checking with the value. So it is greater than 50. It will give the Boolean value. Wherever it is greater than 50, it's 50. Okay. But now if you want to extract, if you want to create a submatrix, from this given matrix, okay, so you just create in this way. Okay, so this is mat 50. Mat 50, it will just give you this Boolean. See, this is actual matrix. This is a Boolean matrix created from this condition. And now if you want to create a submatrix from this matrix, as per according to this one, you just say mat of mat. Okay, so matrix of matrix greater than 50. Okay, that means what? From this matrix, wherever you are having the true value, that will be extracted as a that values will be extracted. Okay, where you are having these values, and this value is true. That value will be, if you want to know that values, you just say mat of mat 50. So first it will consider this function. What will this will give inside? It will give you this Boolean, and on that if you apply mat, you will get these values. Okay, so what? So this 6 positions, that means what? This 6 positions, 51, 99, 53, 61, 82, all these values you can see here, and along with that 97 also should be taken. Okay, 97 also taken. Clear? Is this clear?
Yes, sir.
Okay, so anything you can do. See, I'm saying less than, for example, 22. Okay, so and here if I just say mat of less than 22, I will get only those values. See, in this, everything is less than 22, and wherever it is true, this true, 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 true. Okay, 16, 21, and 17, 19. Same thing is extracted. Okay, so you can apply any condition. Fine. And after that what? Subset. Okay, so after that slicing the same thing we have observed. Okay, but here there is a small catch. Okay, small interesting thing we need to observe. Okay, so over here, so here this is actual matrix, the original matrix. Okay, on this, if you just check, sorry guys. Yeah, so on this matrix, what I'm doing, I am slicing the matrix. Okay, observe carefully, guys. Original matrix created, this is 3 by 3 matrix. Okay, I am slicing the matrix is to 2 is to 2. Okay, that means what? Take is to 2 rows, is to 2 columns. That means is to means n minus 1, 0 and 1 row, and this is 0 and 1 column. Okay, that means what? This 0th row, 0th column, sorry, 0th row first row, and 0th column first column. Okay, 11, 12, 21, 22. This is a sliced matrix. Getting? I want to know,
Yes.
is the slice matrix clear?
Yes, sir.
Okay. From this, what I'm saying, I'm just saying this is slice matrix. Now, in slice matrix is having 4 values. So what is this? This is if you want 11, what is the position of 11? Now see, this is slice. I'm just focusing on the sliced matrix. What is the slice matrix? Mat slice. Okay. Now this mat slice is this. Over here, I'm having 11, 12, 21, 22. What is the shape of this? What is the shape of this?
2 into 2.
22. So this position will be 0, 0. This will be 0, 1. This will be 1, 0. This will be 1, 1. Agree?
Yes, sir.
Okay. So now I'm saying mat slice of 0, 0. That means this position, I'm assigning a new value, 1000. Okay. Now what happened to the mat slice? 1000, everything is same, 12, 21, 22. Agree? Changed? Mat slice. You can assign a new value to the slice matrix also.
Yes,
Okay.
sir.
But the thing here is, now if you go back and check the original matrix, I'm going and checking the original matrix. Now original matrix is also changed. 1000 level 13. See, original matrix is 11, 22, 13. But when I made a change to the sliced matrix, replacing 1000, it is also affecting the original matrix also. Okay. It is affecting the original matrix also. Why? Because a slice matrix is also a part of the actual matrix. Okay. A slice matrix is also a part of the original matrix. So whatever you make changes over here will definitely reflect over there. But if you don't want to do that, you need to create that slice matrix as a separate NumPy array matrix. How we need to do that? Simple. Over here, again, this is original matrix. Instead of just slicing, you need to create it as a NumPy array. Okay. So earlier what we did, we just said mat of is to 2 is to 2. Mat of is to 2 is to 2, that became a slice matrix. But now, instead of doing that, I'm doing NumPy.array of mat. Okay. We're creating a NumPy array out of this matrix. Now that became a separate. Okay. In other words, now this will create a separate memory location. Whatever you do now, whatever you make changes to this mat slice, for example, same thing I'm doing 0, 0, 1000. Now this is slice matrix has become 1000. But what happened to the original matrix? Original matrix is still the same, 11, 12, 13. It did not affect the original matrix. Why? When the moment when you are creating it as a separate NumPy array, this mat slice will be stored in a different memory location. So in that sense, whatever changes you will do, that will not affect the original matrix, because original matrix memory location is different. So this is similar to the shallow copy and deep copy, if you're able to correlate. Are you getting, guys?
Yes, sir.
Clear, right? So if you want to slice it with a separate array. Okay. So whatever you do over here will not affect the original matrix. But if you just take a slice just from the matrix, not as an array, it will, whatever the changes you do, it will affect the original matrix. Okay. Perfect. So, and after that, what do we have? So there are some universal functions like reshape. Same thing we are saving again and again. So 1, 2, 10, 9. So creating 9 values, 3, 3, same. And over here, yeah. So matrix multiplications is what? So this is one matrix, this is second matrix. When you do mat1 dot mat2, this we already seen in the linear algebra. Okay, so you can easily understand it now. So when I'm saying mat 1 into mat 2, it will do element wise multiplication. 9 into 1, 9, 3 into 8, 24, 5 into 9, 45, like that. Okay. Element wise multiplication is mat 1 into mat 2. Fine. And but you also have element wise addition. Mat 1 plus mat 2 will do what? Element wise addition. Okay. Now what do you have? You also have mat 1 at the rate mat 2. What is this? This is a matrix, not the normal multiplication, but this is a dot product of matrix. Okay, that means what? So first row into, see, you have 9, 3, 5. So if I just put it this matrix over here, so it will be 1, 8, 9, 2, 1, 9, 8, 5, 4. Okay, so when you just do asterisk, it will just do element wise, but here mat 1 at the rate mat 2, it will do the matrix. What is that, guys? Dot product. Okay, so what is it? First row into first column. That means what? First row into first column. 9 into 1, 9, plus 3 into 8, sorry, 3 into 2, 6, plus 5 into 8, 40. So what is 9 plus 6 plus 40? 9, 10, 15, 15, 40, 55. Okay, this one. Getting, guys? First row into first column, second row again, first row into first row into first column, first row into second column, first row into third column. Okay, this value. Now if you do 935 into 815, you will get 100. How? 9 into 8 9 is 72, plus 3 1 is 3, plus 5 5 is 25. Okay, 75 plus 25, 100. This is this value, 100. Getting dot product? No? Yes, sir. Okay, cool. So yeah, this same thing. So if you just a recollection, so the other day we have discussed normal scalar multiplication, and we have seen matrix multiplication element wise. Okay, matrix element wise. Okay, and also matrix cross product also we have seen cross product. Okay, that means this I j minus j something. Okay, and also matrix dot product. Okay. Okay, matrix dot product. Fine. So after that, mat 1 by 0. Okay, so that means what? Just dividing matrix 1. What is matrix 1? This is matrix 1 divided by 0. Anything divided by 0 is infinite, so that's why you're getting infinite. Okay, so and similarly 100 plus mat 1 scalar addition, it will just add values, and matrix 1 into 3 into 3 means you will take what? Cube root, or not cube root. Your square root of sorry, what do we call? Cubing. Okay, it's just cubing, not cube root. Okay, so you're just cubing. What you will get? 3 cube is yeah. What is this? 9 into where are we? The exponential matrix cubed over here. Okay, so matrix 1. What is matrix 1, guys? Actually, where did we go? Matrix 1. Matrix 1 is 9. Okay, so 9 cube. Okay, so 9 cube is 3. Wait, I have my doubts. Okay, let me just run this again. I want to be clear. So first of all, let me print it over here. Okay, now mat 1. What is mat 1? This is mat 1. And now when I'm printing over here, yes, this is perfect. Okay, 8 cube what? 8 8 is 64. 64 8 is 112. Okay, 64 8. 512. Okay, 512. This into this is cubing. Okay, and power. Okay. Yeah, power is also same, right? You can do it in 2 ways. Okay, matrix into power into 3 also is same, or you are raising it to the power of 3. Is it clear, guys?
Yes, sir.
Okay.
But we can directly use the power function directly, sir,
Yeah, you
without
can use-
importing the math module.
No. POW is directly. POW you have it from the Python only. I think it's from the math. Did we import math anywhere? Let me see. MATH. Yeah. POW. See, whenever you're getting doubt, right? So you can just write POW. If it is, yeah, it is changing into green color. You see, if I write something, it is black. If I see when I saying POW, it's a by default function of Python. So, and see, min is a by default function, green color, max is by default function. Okay, similarly pivot. Okay.
Okay, sir.
Where are we? Yeah, so you can give to the raise any power. Okay, 7 to the power. Okay, that is. And after that you have something called as broadcasting. Okay, and see, broadcasting is what? See, np dot zeros 4,4. That means what? Create a 4x4 matrix with all zeros. Okay, after that, what? That is start. To that start, what did I do? I just added 1000, so it will become 4x4 matrix of 100. Okay, now np dot array, create a rank 1 nd array with 3 values. Okay, so np dot array 1025. Okay, 1025. I'm creating just one matrix. Okay, 1025. Now what I'm doing, I'm just adding these two. Okay, so start plus add rows. Okay, what is my start? This is my start, and if I add this to everything, so it will, broadcasting is what? So it will do element to element. So 1025 will be added to each and every value. That means 100. See, you just imagine that you are applying this 1025 on top of everything. So for here it will be 1, here it will be 0, here it will be 2, here 5. And what function we are doing? We are doing plus. So 1000. 1 second, what is this thing? So how long will you take still? Just 5 more minutes, don't worry. Or is just we have only one. This is the last thing, nothing much. Can we? Okay, just 5 minutes. Okay, because I don't want to yeah, so continue, take in the next class. Maybe we can start next module. Okay, so just if you see 1025, so it will just add 100 to over here. So 100 will become 101, and 0 will be added to this, so it will 100. So 0 plus 100, 0, 100 plus 2, 102, 100 plus 5, 105. Okay, so 1025 added to every other row, every row. Clear? Okay, so now if you just do transpose, you will get a column matrix. Now column matrix, if you start adding, so what it will do, it will add to the column wise. Okay, earlier it has added to the row wise. Okay, but now it is adding this 1025 column wise. That means what? 100, this for this 101, this for this 100, 0 for this 102, for this 105. Okay, so you will have it in this way. So that is just the broadcasting. Okay, so and also you can add it any other way. So what you're saying, input array equal to 100, so that 100 will be added to each and every value. Okay, so it's just how you can add a separate list to each and every value. Okay, so that is one example of the broadcasting. And after that you have this is very simple, so I'll just give walkthrough. Reshape. So this is matrix, this is second matrix, and square root of matrix 1. Just like how you are having power, you also have square root, so it will just do the square root of these values. Okay, and also you have exponential. Okay, e to the power of, what is exponential? E to the power of this value, e to the power of 4, e to the power of 8, that is exponential, simple. And logarithm also you can use, what is the log of each and every value, that is also simple. Okay, and modular. Okay, if modular is mod. Okay, matrix 1, matrix 2. Okay, it will divide matrix 1 by matrix 2, and whatever be the remainder, okay, whatever be the remainder, it will give you that. Okay, getting? So for example, if you see here, first value by first value, 4 by 9 by 4. Okay, so what it will do, 9 divided by 4, what will be the remainder, guys? So it will be, remainder is 4 to the 8, remainder is 1. Okay, and but when you do 5 by 8, what is the remainder, guys? So 8 zeros are 0, and remainder will be 5. Okay, so it will be 1 5 like that. Okay, so if I just show you, it will be 1 5, and same thing for the others. Okay, and after that, what you are having, combination of line space. Okay, so yeah, so this is simple. So you already know what is line space. What it will do, it will consider starting value and ending value. Okay, and from where to where I'm combining, from 0, it will start from 0. And what is this? This is 12 into np dot pi. What is np dot pi? Pi value 3.14. What is that value? I'm multiplying it 12. So what I'll get, 12 into np dot pi is 37.66699. So from 0 to 37.699, I want to divide this into 1001 equal parts. Okay, it will create 1001. So there will be total 1001, but it has skipped. It will show only first 3 and last 3 with these 3 dots. that means there are so many values in between this. Okay, so it will start from 0 and it will end till this point, but it will be divided this whole space into 1001 equal parts. Okay, guys,
Yes, sir.
understood? Clear? Cool. So that's
Clear, sir.
I would say about the NumPy is so it has just so many functions. Okay, as I said. Okay, so just understanding these basics things should be fine. Okay, but wherever if it is required, I will show you a few more at that time. But these are the most required functions, I would say. So I will share this notebook immediately after this class. So try to go through this over this weekend. Okay, so we have discussed everything right from shape, dimensions, and array, and just to as an array, copy, shallow copy, and from functions. Okay, matrix, arrange, line space, matrix creations and additions, multiplications, diagonals, travels. Okay, k, random number generation, reshaping. Okay, matrix, minimum value, maximum value, indexing, slicing, and subsetting, slicing, and universal functions, and broadcasting, and array math. Okay, so maximum what all required, that is covered. Fine. So that's regarding the NumPy array, guys. So this should be more than enough. Okay, so just go through this, and from Monday, yeah, so from Monday I am going to start the most important module in the whole ML, I would say, is pandas. Okay, so pandas will be started on Monday, same time. Okay, are you good?
Yes, sir.
Cool. Perfect, guys. Yeah, thanks. Thank you so much for joining. So I'll be sharing this in a while. Go through this. Let's meet on Monday. Bye, guys.